Villages, 1370 AM, 96.3 FM, The Source.
All right, 25 minutes before 11 o'clock. Have you ever gone to a gathering of like stock market people, like stockbrokers, rich people, in other words, right? You have to fake it, right? You're standing there with your glass of tea or whatever. And they're yapping about the stock market, and you go, I've been to Wall Street. That bull is something else, huh?
Yeah.
And they realize, okay, this guy has no clue. Let's talk about the statue of the bull. Same thing is true when I'm with people who are really smart, like science people, astronauts, for example. I never know what to say. I know what an exoplanet is. You know why? Because I know what an exoskeleton is.
Yes.
Because of like something in science, right? It's an animal, right? And so once again, I'm going to show that I really don't know anything about this. However, I can say that I'm old enough to remember standing out on the sidewalk when man landed on the moon. I remember looking up at the sky to see this. Dr. Joshua E. Schlieder is on the phone. He's a research astrophysicist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. How impressive is that? Just that alone. That's got to be a chick magnet, right, Robin?
He is. Those credentials? He's hot. I visited his website. He looks like he's taking a selfie.
All right, listen to this.
He wants a nice smile.
He wants to talk to us about TESS, transiting exoplanet survey satellite, the new NASA mission to discover thousands of new worlds orbiting nearby stars.
That is cool.
Holy cow. I love this kind of stuff, by the way. Good morning, Dr. Schlieder. It's an honor to have you on our show.
Good morning. Thank you so much for the nice introduction. I'm happy to be here.
Oh, thank you. I hope it was a nice introduction. I don't have a whole lot of experience with astronauts, except that I have looked at the moon. I have done this. Isn't that cool, though? I mean, when you look at the moon, is that where it started for you, your interest in this field? Was it looking up in the sky as a kid?
I mean, honestly, yeah, I grew up in a pretty rural part of Pennsylvania, and we had really dark skies, and, I'd go out at night and just sort of take a look at the moon and the stars and constellations, and once in a while there'd be a planet in our own solar system that you could see, Jupiter, Saturn, Venus. Got a telescope when I was about 12 years old for Christmas, and then it just built from there.
Is that right? Wow. Did you subscribe to Sky and Telescope magazine?
I certainly did, and Astronomy magazine.
See, I have a brother that would be better for this interview than me, because he was the same way. He got a telescope. He subscribed to that magazine. So when we look up in the sky and we try to imagine what it's like up there, how do we know? I'm always amazed. I mean, the math part of what you do. What was that movie we saw, the Hidden Figures, the three women?
Yes, that was amazing.
The math part of that movie showed us that without the exact calculation, we would miss a planet by millions or thousands of miles or something, right?
Yeah. So the math is quite complex. I mean, that's true. And actually, for finding planets around other stars, some of the hardest math is actually calculating how to get the telescope up in orbit around the Earth. The rocket science, so to speak, is pretty complicated. But the method that we use to detect planets with the TESS mission is actually pretty straightforward. And what we do is the telescope, the spacecraft carries 4 small telescopes, and they all sort of work together to give a view of a very large portion of the sky in one shot. And these 4 telescopes just stare at a part of the sky, and they monitor the brightness of thousands of stars at one time, once every couple minutes, and look for dips in the brightness as a planet passes in front.
And do they have, does TESS have a particular orbit that it's going to follow, or is it kind of like on its own?
Yeah, so TESS has an orbit. Typical satellites like maybe the Hubble Space Telescope or even the International Space Station people are familiar with orbit in low Earth orbit, just a couple hundred miles up. And TESS is in a high Earth orbit, which means that it's much further out from the Earth, but still going around the Earth. And it actually swings pretty far out toward the orbit of the moon, and then it dives back in pretty close to the Earth. And it takes about 2 weeks to take this oval-shaped orbit around.
Wow. Okay, so now this is lifting off on Monday, this coming Monday?
That's correct. Yeah, Monday evening.
Okay, and is it from Cape Canaveral?
Indeed, yes.
So we'll be able to see it. This is where my nerd comes out. Okay, because I love looking, because we are northwest of that. So if we look southeast, if it's a clear day, we can see every launch. I don't think,
yeah.
As long as it's clear. So we'll look at it. We'll know what this is about then. A lot of times a rocket goes up, we don't really know what it's about.
Yeah. So this is this mission is getting launched on Monday, as you said, and its goal is to find these planets around nearby stars. And as you watch the rocket go up, you can think that in the pretty near future, you'll be able to go outside at night and look at individual stars in the sky that you can see with the naked eye. And the TESS mission will find some planets around those stars that are that bright. So we'll be able to go out in our backyards, point up at particular stars, and say that we know that star hosts planets like our solar system.
So help me understand. I know you explained it, but I just wanted to see if I got it. So you know there's a planet at a distant star by the diminishing light from that star because it casts a shadow? That's it?
That's right. Yeah, that's what TESS does. It monitors the brightness of the stars with very high precision.
Wow.
And looks for these little dips that happen, in a regular pattern. And the size of the dip is indicative of the size of the planet. A bigger planet blocks out more light. And how often the dips happen indicates how long it takes that planet to go around its star.
Do you have?
Wow, that is so fascinating.
Do you have any particular ideas of what the terrain is going to be like?
So we don't. The TESS mission gives us just these brightness measurements and, the size of the planet and how long it takes to orbit the star. But because we found so far since the mid-1990s, we started finding exoplanets. We found, over 3,000 of them at this point. And we have a big enough sample that we can now start to understand how the population changes. Small planets tend to be rocky like the Earth. Big planets tend to be gas giants like Jupiter and Saturn. And then there's some stuff in between where we're still trying to figure out where that transition between a rocky and a gas planet happens. But, the radius itself is a pretty good indicator if it's going to have a rocky surface or it's just going to be a big ball of
Really?
gas.
So is Mars kind of like old hat for you? I mean, we're all excited about Mars, but you probably were through with Mars a decade ago.
Mars still has secrets to hold. We keep learning more, and Mars, we find planets out there around other stars that are, some of them are as small as Mars. That's really hard to detect because the drop in brightness is tiny, just a tiny fraction of a percent, but we can detect it. And, Mars, we keep sending robots there, and they keep finding more and more interesting things, evidence for past water, and, it's a really interesting place that's more tangible than what we're looking at with TESS. But it all fits in together because planets are planets, Mars and Earth and Jupiter, those things, they exist around other stars, and we now know that, and we're out to find more.
Are you hoping that there's something unique on those other planets or on those moons like you see in the science fiction genre, like diamonds and things like that on, covering a planet?
So we found, with previous planet hunting missions like NASA's Kepler mission, we found really bizarre planets, things that we never expected to find. Imagine this. We found there's a lot of stars out there that host planets that are as big as Jupiter. So it's so big that you could fit, 100 Earths inside the planet. But they are on an orbit around their star that takes only days.
Wow.
And so they're giant planets super close to the star, baking in the heat, temperatures of thousands of degrees.
Oh my
we never
gosh.
thought we'd find that.
Wow, that's
and
amazing.
so, there's all kinds of interesting things out there. The universe likes to keep its secrets until all of a sudden there they are, and we have to figure out how that happened.
So I have an Earth question based on a news story just earlier this week, I think it was. And then if I could ask you to apply that to your research that you're doing with other planets. Okay, the story was this, that science has noticed that the tides of the oceans caused by the moon actually create some kind of a magnetic field. And to be honest, I read the story and it was over my head. I didn't understand the significance of that. So do we, in other words, I guess what my question is, do we need a magnetic field in order to survive on a planet? Is that part of what makes life, is the magnetic field?
That's a really interesting question, and it's something we're actively pursuing now in exoplanet science. And, we're trying to understand, are there other planets like the Earth, truly like a rocky planet with water on the surface and a nice atmosphere? And we're on the track of it. We're finding things that, are potentially like that, but we just don't have enough information to verify it. And something that makes the Earth a great place is exactly that, a magnetic field. And that magnetic field protects the planet from the harsh radiation from the sun. The sun spits out lots of high-energy particles when it gives off flares and other things, and our magnetic field traps those particles and sort of keeps them away from the surface, which protects us here on the surface.
Isn't that amazing?
If other planets don't have magnetic fields, for instance, Mars lost its magnetic field a long time ago, and now it's a dried-out cold desert. And so that could be the reason why Mars is no longer like the Earth, no longer a wet planet.
Wow.
Because it lost its magnetic field. And so if a planet is truly going to be like the Earth, it may indeed have to have a magnetic field to protect it from the influence of its host star.
Can I just extend the question one little bit more?
Sure.
The astronauts in the space station, are they? Does the magnetic field, aside from keeping them in orbit, for their life, for the life that they have, everything? I mean, does that need to be there? And is it on the moon? I mean, could we live for very long on the moon?
Yeah, so in orbit, in low Earth orbit around the Earth, places where like Hubble flies and the space station, we're still somewhat within the magnetic fields of the Earth. They extend pretty far out there, and astronauts are indeed, somewhat protected in that part of space. But they do receive more radiation than we do on the surface. And mentioning the moon, when astronauts went to the moon in the 1960s for the first time, they experienced these strange flashes of light that they were seeing, and they didn't know where they were coming from. And it turned out that they were actually particles in space going into their eyes and interacting with the inside of their eye and causing a flash of light.
Oh,
and so
wow.
When you get out there toward the moon and you're well beyond, the Earth's protective field, you can really get hit with some serious particles. And the surface of the moon is the kind of place where you'd have to be pretty protected to stay for a long time.
Wow.
It would be pretty harsh.
Does that explain the story the other day? I can't remember which astronaut took a lie detector test or something, and the news was that he said there were UFOs on the way to the moon. Did you see that story?
Oh, I did not see that story. I'm not sure about that, but I do know that they experienced, like I said, these flashes of light, and they didn't know what they were, and it turns out that it was actually particles coming from space interacting with their eyes.
So what planet rains like gems, like diamonds and stuff? Which planet does that?
So I don't know the name of it, but we found planets that are out there that, so these planets that we're talking about where we've mentioned, seen some news articles where they rain gemstones or rubies or sapphires, I think it was mentioned in the past. And what's actually happening there is that these are big gas giant planets like Jupiter and Saturn, and they're very close to their stars, as I mentioned. We found a few like this. And they're so hot that the clouds in their atmospheres are actually basically like melted rock. And when the melted rock cools and sort of precipitates, like when we have clouds of water vapor in the sky on Earth, and they cool and the water falls to the surface as rain, you could imagine if it was a couple thousand degrees, that could be melted rock vapor, and then that would condense, and it could rain down little particles of, potentially sand or as was mentioned, gemstones or something like that. And so really extreme environments we're finding in these exoplanets. And like I said, surprises, around every corner that sort of have to change the way we think about the planets in our solar system and our own Earth.
It's
think
so fascinating.
about the uniqueness of the Earth. Yeah.
Will this mission be able to see stars that are dying and that they explode and they're no longer there?
So that's a really great question. So TESS was designed from the ground up, over many years to discover exoplanets around other stars. But as I said, it has a very simple observing scheme where it just monitors the brightness of all these stars in a giant part of the sky once every few minutes. And in doing so, anything that happens in that part of the sky that changes brightness over time, TESS will be sensitive to, and it will measure it. So if it happens to be looking at a part of the sky and it stares at each, we call them sectors in the TESS mission, each sector for about a month, if a star explodes in that part of the sky while it's observing, TESS will absolutely detect it and measure, that stellar explosion, which is another great thing about the TESS mission is that it's designed for planets, but it's a boon for all of astronomy. All this other science can be done with the data from this mission.
So I've had a question for a long time about the amount of time it takes light to get to us. Okay. So here's my theory. If you could have an observation station, observatory, whatever, on Pluto, let's say, and I don't know how much time it takes for light to get from Pluto to here. Do you have that? Is that something we know? Or
yeah, let's think about that. So Pluto is about 40 astronomical units away. The Earth is 1 astronomical unit away from the sun.
Holy cow.
So the light from the sun takes about 8 minutes to get to Earth from that distance. So it's 8 times 40 is 320 minutes it would take to get to Pluto at the speed of light.
Okay, so listen. Here's my idea. I know this is probably science fiction, but if we had an observatory up there, right? And it saw a star explode, and the star is, 6 billion years away or whatever. I don't know how that is. Okay. It could radio to us, hey, aim your telescopes this way because we just saw one. Right? Because we would have a couple of hours to get lined up. We would know. Right?
Yeah. I mean, the problem is that all this information travels at the speed of light, including the radio signals. And so if you have something out at Pluto, Pluto, if you're at Pluto, you'd see it a few hours early, right? But then you'd have to radio back to Earth, and the radio would take a few hours to get here.
Okay. Never mind.
It's all moving at the same speed. So it's a great idea, and it would be interesting to have something so far out there. But unfortunately, the speed of light is the limit, and we can't go faster.
This is why I do radio.
Do you have any names in your archive for the new planets that will be discovered?
So we as scientists, I'm going to be honest, we're kind of boring in the way we name planets. In order to keep track of the planets that we're finding and what missions find them, we tend to give them sort of catalog numbers as names.
Really?
For example, the Kepler mission, which was really successful, found thousands of planets. All those planets that it found are called Kepler dash a number, which is sort of numerical order of what they're discovered, and then a lowercase letter that indicates what planet in the system we're talking about. So the second planet in the system around the 129th star that had a planet from Kepler would be Kepler 129c, for example.
Really?
So have if everything is in maps form then?
Basically,
maps.
We've got these catalog numbers, and we can keep track of what mission discovered it, when it discovered it, and what planet in the system we're talking about.
So when we hear this ad on the radio that says, name a star after your father or whatever, right? I mean, are we really doing that, or is that just somebody making money with a book?
There's a registry of names that are kept out there, but in the scientific community, we typically just call things by catalog numbers because they're more descriptive, and then everybody knows what exact star or planet that we're talking about.
So Robin and I have a children's act. We call ourselves Robin and the Giant because her name is Robin and I'm big. Okay.
Yeah.
So if you happen to find 2 planets, a small one and a big one.
Yeah.
I'm just saying, could you?
Yeah.
Okay. I jotted that down. We'll keep it in mind.
All right. Now here's my serious question. Okay. So let's say you find an exoplanet. And it's let me ask you it this way: how close is the nearest exoplanet that's been discovered so far?
That's a really great question, and it has a really cool answer. So, just a few years ago, in 2016, we discovered that the closest star to our sun actually has an exoplanet, and so it is 4 light years away, which means if you travel at the speed of light, it would take you 4 years to get there.
Oh, man.
And so it has a planet. The planet goes around the star once every about 11 days, so it's on a really fast orbit.
Wow.
But the planet is probably about the size of the Earth. And the star is a really small, faint little star, much, much smaller than our sun.
Oh, really?
And so even on an 11-day orbit, it's still in the region around that star where we think it would be the right temperature for liquid water on the surface, if it has any water or an atmosphere or anything like that. And so
Christmas would come every 11 days, basically.
That's right. Yeah, a year takes 11 days. So it's a really bizarre system, but that's the closest exoplanet we know of. And so, we've pointed a lot of telescopes at this star and learned a lot about it, and it's certainly going to be a topic of further research well into the future.
If there was somebody on a planet like Earth in a different solar system, when they're looking at the planets in our solar system, do we appear as stars to them?
Yeah, I mean, we would just look like a star because what you see is the light from the sun, and then If they use similar technology to what we use, like the TESS mission, looking for drops in brightness, if they're oriented the right way, sort of looking at our solar system edge on so they see the planets pass in front of the sun, they could see a transit of a planet across the sun and say, hey, there's planets there. And the problem with our solar system is that it takes, about 90 days for Mercury to go around the sun one time. So they'd have to stare at our solar system for 90 days straight to just see Mercury pass in front one time. And to see Earth pass in front one time, they'd have to stare for a year. And so it's a hard business to discover our solar system from far away.
Mm-hmm. Do you drink?
Do I? Yeah, I have a drink once in a while.
So let's say we're at a party, right? And you got a few in you, and now you're at that point where you're gonna be totally honest with me, right? Because when people get just a little bit drunk, they become really honest. What do you? If you're in that state of mind, what do you think of Elon Musk? I'm just curious.
Yeah, there you go.
I think Elon Musk is a great entrepreneur in our country, and NASA has a very strong commercial partnership with SpaceX, Elon Musk's company, and he has a vision for his companies and for humanity in general, and he wants to go back to space, and he wants to make space a place where we do business. And,
all right, so that helps
NASA,
us.
NASA's partnering with Elon to do this, with SpaceX to do this launch with TESS. And that commercial partnership allows NASA to do things at lower cost, and it gives great companies in this country, a revenue source to keep developing new technology. So
it's good to hear that.
It's good for us. Yeah.
Well, it's good to hear somebody who knows what they're talking about, respects the guy. Here's why I questioned him, because again, I only do radio. He's sending a rocket up to test a possible one-day flight to Mars. He's got a car in the top of the thing with a mannequin in it, right? And then he announces, we missed. It's going to be off by 1,000,000 miles. Well, what if that was a real person? That wouldn't be good. A million. That's not good.
Well, I'm going to say, going to space is hard, and it's always a risk. And honestly, the first time that you test a new rocket, like they did with that Falcon Heavy rocket, it's better to send a mannequin than a person. And so I think that's what we learned from that experience.
Yeah.
And so you work the bugs out without people's lives at risk. And then when you're sure what you're doing, then you move forward.
I told Robin that we might want to consider this because we'd be the biggest radio show on the planet.
Exactly.
If we went up there. This is so much fun. I am a geek when it comes to this stuff. I love visiting the Kennedy Space Center. I'll be honest with you, much of it is over my head. The math, how you do this stuff is over my head. But from the layperson's point of view, you know what we like? We like looking at the pictures. Will we be able to see the pictures from TESS?
So the pictures that TESS is going to take are going to be, sort of ho-hum, I would say. They're just going to be big pictures of all the stars in a big part of the sky. And, as I said, it takes a picture, once every couple minutes, and then we look at how the brightness changes with time. And so, unfortunately, the images coming from TESS are not going to be all that outstanding, not like the things that Hubble produces with very vivid colors and pictures of galaxies and things like that. But when we find some interesting planets, we'll learn what we can, and then be on the lookout for some artist conceptions of what those planets might look like, given what we've learned from TESS and other observatories that will follow on and what we know about planets in our own solar system. I think there'll be some really nice artist impressions of planets that TESS finds.
Gosh, you are amazing, Doctor.
Really fascinating.
And fun.
Yeah, who knows? One day maybe there will be life on another planet or something. Thank you so much for being on the show with us today. Let's leave the audience with a website if you have one. Do you have a website?
Yeah, sure. The audience out there can follow us at nasa.gov/TESS, TESS. And if you're into social media, please follow us at NASA Goddard to get all the updates about the launch coming up on Monday. They can even tune in on NASA TV, which has a YouTube channel, to watch the launch live and see the rocket go up.
Yeah.
Oh, wonderful.
And here in Central Florida, you should be able to see it if it's a clear day.
Yeah. Around 6:30 on Monday, take a look.
6:30 a.m. or p.m.?
PM, evening launch.
Okay, all right,
nice.
Good. Hey, thank you so much, Doctor. Thank you for being on the show with us today. Dr. Joshua E. Schlieder. Thank you, Doctor.
Yeah, thank you. It's been really a pleasure. It's
you.
Great. Thanks.
We'll be right back.
Bye-bye.
Broadcasting from the Paddock Mall Studios, this is WOCA, Ocala, Gainesville, The Villages, 1370 AM, 96.3 FM, The Source.
Fox News Radio, I'm Chris Foster. President Trump tweets about airstrikes in Syria could be very soon or not so soon at all. There are options.
The guided missile destroyer USS Donald Cook has been patrolling the eastern Mediterranean since Monday, ready to fire its roughly 75 Tomahawk